Hi everyone, we are students from UTM. In this video, we will introduce and explain the applications of amplitude modulation in aviation systems. An aviation system is the complete set of technologies and equipment that help aircraft fly safely, communicate, navigate, and be controlled during flight. Amplitude modulation, AM, is a communication technique where the amplitude, strength, of a high-frequency carrier signal is varied according to the message signal, such as voice or music, while the frequency remains constant. Amplitude modulation, AM, in an aviation system is a communication method where the strength, amplitude, of a radio signal is varied by the pilot's voice to transmit information between aircraft and air traffic control. Now, let's invite our member, Jun J, for giving further explanation.
Aviation communication system mainly operates in the very high frequency band, which ranges from 118 MHz to 137 MHz. This frequency range is internationally standardized and widely used for the communication between pilots and the air traffic controllers. 121.5 MHz is designated as the aircraft emergency frequency. It's used globally for distress, emergency, and urgent communications and cannot be used during the normal condition. Very high frequency signal transmit through line of sight propagation. The radio waves travel in a straight line directly from the transmitter to the receiver. Because of this, very high frequency signals can be easily blocked by the physical obstacles such as buildings or mountainous terrain, and the coverage range will be low. Hence, the traffic control tower is high and airfield should be spacious. Low bandwidth usage is preferred because it allows efficient use of the limited radio frequency spectrum while still maintaining the clear voice communication. Generally, the maximum voice frequency is 4000 Hz. The bandwidth for the amplitude modulation is twice of the maximum message frequency. Hence, the bandwidth required is 8000 Hz. Traditionally, aviation communication channels use a 25 kHz channel spacing. This wider spacing helps prevent interference between adjacent channels and ensure the reliable communication. To reduce frequency congestion and increase the number of available channels, a narrower spacing of 8.33 kHz has been introduced, especially in the VGS space. This allows more channels to be accommodated within the same frequency band. Additionally, a wider spacing of 100 kHz is allocated for the aircraft emergency frequency to ensure maximum reliability and minimal interference during the distress situation. In AM, the signal is vulnerable to the noise because noise directly affects the signal amplitude. As a result, AM signals are more susceptible to the interference. However, aviation communication operates in the very high frequency band, where the atmospheric noise is generally lower. This reduces the overall impact of noise on the received signal. Despite this, noise can still lead to the poor signal quality and unclear voice communication. For this reason, pilots and air traffic controllers undergo extensive communication training. Here is the example of the aviation communication.
Executive Tower, Tower 73929, highlight 25.
And
Executive Tower, Tower 73929, highlight 25.
Pilot say. The aviation communication uses the super heterodyne receiver to receive the modulator signal. It can convert the received radio frequency signal into a fixed intermediate frequency signal. By using the fixed intermediate frequency signal, the receiver can achieve the better performance in terms of filtering and amplification, so the filter will be cheaper to be implemented. Hence, it can improve the sensitivity as the signal will be amplified multiple times. The super heterodyne receiver will also improve selectivity, effectively separating the desired signal from the nearby interfering signals. For the super per heterodyne receiver, the antenna will first receive the signal. Then the received signal will be amplified. Next, the signal will be mixed with the local oscillator signal to produce the intermediate frequency signal. Then the filter will filter out the desired signal. Finally, the demodulator extracts the original information and it will be boosted so it can be heard easily.
Conclusion: Amplitude modulation double sideband full carrier is widely used in aviation communication because it is simple, reliable, and allows multiple signals to be heard simultaneously, which improves flight safety. Although amplitude modulation is sensitive to noise, its compatibility with super heterodyne receivers and very high band operation make it suitable for clear and dependable aircraft ground communication. That's all for our presentation today. Thank you very much.